Next, let's look at an example here. This example, that's the question here. The question is given that random variable x is uniform distributed from 2 to 3. We want to find out these two probabilities here. First of all, for any questions, if the question tells us this random variable is uniformly distributed from somewhere to somewhere, we should be able to transfer this sentence into the PDF function. So we want to make a connection of what is the PDF function for any uniform distributed random variables. If the random variable is uniformly distributed from 2 to 3, so the PDF function is this. It's from 2 to 3, it has some values. The value is 1, which is 1 over 3 minus 2. So next, let's look at this probability. We want to find out probability of x greater than 2.5. And this, I want to point it out that this probability is actually equals to probability of x greater or equals 2.5. The only difference from left-hand side to the right-hand side is only just 1 point, equal sign of 2.5. I wanted to point it out, emphasize that this equal sign does not make any difference in this probability here, because there are infinite number of points along this real line. So 1 point does not make any difference. Any random variable is continuous, equal sign does not make any difference in terms of probability. But for discrete, it will make difference. Okay? For discrete random variables, it will make difference. So we need to be a little careful when we deal with discrete random variables. Because of this PDF function has two values, 1 or 0, so we need to separate this integral into two intervals. This is a 2.5 to 3 and 3 to infinity. So the probability is 2.5. So next question is probability of x between 2 to 2.5 here. So again, this is the area between 2 to 2.5 under the PDF function. So integral from 2 to 2.5, plug the values in. So this is a probability equals 0.5. Next, let's look at more examples about the expectations and variance. So let's use an example of random variable x is uniformly distributed from -1 to 3. So we want to find out the expectation of x, variance of x, and we also want to look at the expectation of x squared. Again, before solving all of these questions here, we need to know the PDF function. So PDF function, that's the key to calculate probability, to calculate expectations, calculate the variance. PDF is the key to start with. To make connection of the PDF function of uniformly distributed, we know that, okay, it has rectangular shape. When x in between -1 to 3, it has the height. It has a value of 1/4. Otherwise, it's 0. How do we calculate expectations? So we take the random variable x and multiply by the PDF function. We do integral from -infinity to infinity. In this case, 0 values outside -1 to 3. So we only have values from -1 to 3. So what's the value for the PDF function? Only 1/4. This integral from -infinity to infinity, we do integral in this case from -1 to 3 because the property of the PDF function here. -1 to 3, x, PDF function, that's 1/4. You do the integral. So this, you evaluate this numerical. So this is the expectation. Next, we want to find expectation of x squared, because this expectation of x squared help us to find out the variance. So this is the variance expectation of x squared minus expectation x squared. To evaluate this expectation of a function of x, we need to know this. This is true for all random variables. And this relationship can be proved, but at this moment, we're not going to bother for the mathematical proof. We just use it. This is the expectation of gx. This is any function of g of random variable. What is this equals to? We do the integral from minus infinity to infinity. The function multiplied by the PDF function. Expectation of x squared, we take x squared. That's the function of this is the function of a g here. And then fx, you do the integral. So again, it has from -1 to 3. The values is a quarter x squared. This integral is easy to evaluate.